Equations of lines. Equation of a line passes through two given points. Let us consider a line passes through two points P x1 y1 z1 and Q x2 y2 z2 with position vectors vector A and vector B respectively. Let us consider a point R with coordinate x, y, z having position vector R. What I'm going to do, I'm going to consider this information and then I'm going to graph on the 3D plane. So as you can see, this is my x-axis, this is my y-axis, and this is my z-axis, and this point is my origin O. At first, I'm going to consider this point, which is my P with coordinate x1, y1, z1, and this is my point Q with coordinate x2, y2, z2. I'm going to consider another point between P and Q. Not necessarily you have to consider a point between P and Q. You can consider anywhere, but I am considering between P and Q. So let this is a point R with coordinate x, y, z. Now, what I'm going to do, I'm going to connect these 3 points using a line L. So this is my line L, and this line is connecting all the 3 points P, Q, and R. Let the position vector of point P is A, let the position vector of point Q is B, and position vector of this point R is vector R. Then point R can be on the line if and only if PR is basically what? Vector R minus vector A, and PQ is basically vector B minus vector A. Because what we are trying to do, we are trying to use the position vector to find vector PR and PQ. If you look at the picture, as you can see, PR and PQ, they are representing the same line. So technically what I can say PR and PQ are collinear vectors. And this is the one condition that tells us that point R lies on the line L. As you know, PR and PQ are collinear vectors, so we can definitely write PR is equal to some constant times PQ, which is over here. So PR is vector R minus vector A is equal to K times vector B minus vector A, where K is a constant. If you remember from the geometry that if two lines are collinear, then one line should be some multiple of another line. And that's what we are doing. We are saying that PR is some multiple of PQ. If we further simplify, what we will do, we will take this vector A to the other side, and if I do that, I can write vector R is equal to vector A plus K inside the bracket vector B minus vector A, which is over here. And this is the equation of a line passes through 2 points P and Q, and this type of equation is known as vector form of equation. Now let's find the Cartesian form of the equation. So the Cartesian form of the equation of line L is given as x minus x1 over x2 minus x1 is equal to y minus y1 over y2 minus y1 is equal to z minus z1 over z2 minus z1. If you look at the denominator, all these are some numbers. So basically, in my opinion, you can call these constant at the denominator as direction ratios. And if you remember our equation from the last slide, the equation was exactly the same thing, except the denominator was written in terms of A, B, and C, or L, M, and N.